To our training module on rolling contact bearings, one of the most important inventions ever made by man. First, we're going to spend a few moments explaining why man invented bearings in the first place. Way back, a few thousand, or maybe a few million years ago, man invented the wheel. Being the ingenious creature he is, always looking for an easier way to do the job, man used the wheel to eliminate blisters on his feet and an aching back. In other words, he used the wheels on a cart to haul him and his treasures from one camp to another. Since there really wasn't too much happening back in those days, man wasn't in too much of a hurry, and he took his time whenever it was necessary to travel by wheels. Unfortunately, all good things must come to an end, and early man came face to face with his first good reason for high speed. The men pulling the cart were very highly motivated. Their motivation was simply self-preservation. And as we all know, the principle of the wheel is good. It worked then, and it still works now. There was only one problem. There weren't any bearings between the wheels and the axle on the cart. The result was friction. Friction does two things. It creates a dragging effect, and it generates heat. The high friction and the heat set the wheels of the cart on fire, slowing down our hero's escape. The result was quite simple. Early man learned, the hard way, that moving parts and fixed parts, like wheels and axles, must have bearings between them to reduce the friction and heat. After thinking about this tragedy for a few thousand years, man invented the sleeve bearing, like this one. The axle, or shaft, was placed in the sleeve bearing to reduce the friction and heat, a good step in the right direction. The only problem with the sleeve bearing is that there is still some friction, and it requires quite a bit of power to turn the shaft or axle in the sleeve. The reason is that the sleeve bearing is a sliding bearing. It works in much the same way as the cement block being pushed along the floor by this man. Although the block does move, it requires a good deal of power to move it. Although the sleeve bearing works, and is in wide use in larger machines today, man continued to look for a bearing that would operate at high speeds with less friction. In a few thousand more years, man came up with the solution that put all dinosaurs behind museum doors: the rolling contact bearing. A rolling contact bearing is a device used to mount rollers or balls between a fixed part of a machine and a moving part. As you can see, the man is able to turn the shaft in the rolling contact bearings with only 2 fingers. The reason is shown in this illustration. The cement block rolls along the floor with only a 1-finger push from the man. The rolling contact bearing generates less friction and requires less power. Those are the primary differences between the sliding contact sleeve bearings and the rolling contact bearings. We will be dealing with 2 classes of roller contact bearings in this training module: the ball bearing and the roller bearing. This is a cutaway view of a ball bearing. As you can see, the ball is simply a highly precision metal sphere. The other type of rolling contact bearing is the roller bearing, as shown here. The basic roller bearing is a highly machined solid metal cylinder. Here is an illustration showing both of the roller contact bearings, the ball and the roller. For your information, the ball bearing may be used in much higher speed applications, while the roller bearing is used in slower speeds. The primary difference between the two bearings shown is illustrated with the arrows and the red areas, which represent load capacities. As you can see, both of the bearings are the same size, as shown by the horizontal arrows at the top of the illustration. However, the roller bearing on the right has a much greater load capacity than the ball bearing on the left. Again, as we said, the amount of load the bearing can handle is indicated by the arrows and red areas. In short, in two bearings of the same dimension, the ball bearings can be used in higher speeds, and the roller bearings for greater loads. Now that you've seen the two basic classes of rolling contact bearings that we'll be dealing with in this training module, let's take a closer look at the way they're put together. This is a typical ball bearing. We will use it as an example to show the component parts of most ball and roller bearings. Here is a graphic illustration of the ball bearing we were just looking at. There are four basic parts that make up the majority of common ball and roller bearings now in use at most plants. The first part is the outer race. On the right is a side view of the outer race, and the illustration on the left shows a cutaway of the race. As you can see, there is a raceway in the race, which shows up as a rounded groove. The balls of the bearing will run in this raceway. The part you now see in green is the inner race. As you can see, it fits inside the outer race, and looks much the same, except that the raceway is on the outside of the race. It is now obvious how the raceways are used to contain the balls in the bearing. This illustration shows the balls in position between the inner and outer races. As you can see, they roll in the raceways we described to you a moment ago. Before we go on to the next step of this presentation, we want you to think about the balls as shown between the two races. The illustration shows the balls evenly spaced around the circumference of the races. These are the way the balls must be positioned for the bearing to work effectively. The only problem is they won't stay that way. If you turn this bearing, as shown in the illustration, all of the balls would roll to the bottom half of the bearing and jam together. For this reason, a bearing cage is installed as shown. The cage is designed to separate the bearings at specific intervals, ensuring that the balls are spaced evenly around the races. This cutaway illustration of the bearing shows you all of the parts we described. It shows the inner and outer races and the balls as they roll in the raceways. It also gives you a good picture of the cage and shows how the cage serves to isolate the balls from each other. Here is another illustration, very similar to the one you just saw. The only real difference, as far as the parts are concerned, is that this bearing is equipped with rollers instead of balls. All of the other parts are the same, both inner and outer races, and the cage to separate the rollers. You will encounter one basic variation to the nomenclature we've just presented. Some roller bearings have different nomenclature for the inner and outer races. The outer race is called the cup, and the inner race is the cone. Here is a bearing equipped with an accessory that you should be familiar with. Both sides of this bearing are covered with a seal. The seal is used to seal contaminants out and to seal the lubricant in. The lubricant sealed inside this bearing is supposed to last for the lifetime of the bearing. Another accessory that looks very similar to the seal is a shield. The shield regulates the flow of lubricant through the bearing, as well as guarding the bearing against contaminants. The primary difference between the shield and the seal is that the seal seals the lubricant in. The shield does not. Now that you are familiar with the basic nomenclature of rolling contact bearings, let's spend a moment on the operating principles. In other words, how does the bearing work? As we mentioned earlier in this segment, moving parts and fixed parts must have bearings between them to reduce friction and heat. Let's use the end of this pump as an example. This housing is the fixed part. It does not move. The shaft is the moving part. It rotates at very high speeds during operation. There is obviously a need for some device between the shaft and the housing to prevent friction during operation. The device is a rolling contact bearing, either ball or roller type, depending on the pump. The bearing is installed in the housing like this. The outer race of the bearing has a close sliding fit with the housing. In other words, the outer race becomes part of the housing and does not move during the operation of the pump. The inner race of the bearing has an interference fit with the shaft, which in effect makes the inner race part of the shaft. This means that the inner race of the bearing will turn at the same speed as the shaft, while the outer race does not move. The balls, or rollers, then roll between the two, reducing friction and heat. We'll tell you more on roller contact bearings and how they are designed to work under various loads and conditions after you complete exercise number 1 in your workbook. This segment of our course on rolling contact bearings covers basic types and variations of bearings now in use at plants around the country. As you already know, there are 2 basic classes of rolling contact bearings, the ball and roller. These classes are then broken down into 3 types: the radial bearing, thrust bearing, and radial thrust bearing. This is a radial bearing. It is designed to withstand radial loads as shown in the illustration. A radial load is a load at right angles to the axis of the shaft. In short, a radial bearing confines the shaft, preventing it from moving up, down, sideways, or any combination of the 3. This is a thrust bearing. It is designed to withstand thrust loads, as shown in the illustration. A thrust load is a load which is parallel to the axis of the shaft. The thrust bearing also confines the shaft, preventing it from moving back and forth, as shown here. Our third basic type is a combination of the first 2, a radial thrust bearing. In other words, a radial thrust bearing will confine the shaft both radially and axially. It will prevent the shaft from moving back and forth, as well as up and down or sideways. The radial thrust bearing is also called an angular contact bearing in most plants. Once again, a radial thrust bearing is also known as an angular contact bearing. Remember, there are 2 basic classes of rolling contact bearings, the ball and the roller. They are further divided into 3 types: radial, thrust, and radial thrust, also known as angular contact. The 3 types may be found in either of the 2 classes. By way of explanation, there are both ball and roller radial bearings, thrust bearings, and radial thrust bearings. Once the bearings have been divided into the basic classes and types we described, there is a wide variety of variations. We'll show you a few as examples. This is a single-row ball bearing. As you can see, it gets its name from the single row of balls in the bearing. It is a radial bearing, one of the most common now in use. This is a double-row ball bearing. The reason for the name is obvious, due to the double row of balls in the bearing. This is also designed primarily as a radial bearing and would be used for heavier loads. Our third example is a pure thrust ball bearing. It's obvious that this bearing is designed differently to do a different job. The races, instead of being inside and outside, are positioned side by side, with the balls between them. The pure thrust bearing would be used in a situation where one race is positioned against a shoulder on the shaft and the other against the housing. It would then be used to absorb a pure thrust load. Our fourth example of ball bearings is a radial thrust bearing, also known as an angular contact bearing. It is used in situations where both radial and thrust loads must be carried by the bearing. This illustration shows what we mean. As you can see, the difference is in the races. They're designed to withstand angular loads, or in other words, a combination of radial and thrust loads. As we mentioned earlier in this segment, each class of rolling contact bearings, both the ball and roller, have the same basic types and variations. For example, this is a cylindrical roller bearing. The name comes from the rollers, which are shaped like cylinders. The cylindrical roller bearing is designed primarily for radial loads and can withstand considerably more load than a ball bearing of the same size. Here is a double-row roller bearing. It is called a spherical roller bearing and is designed primarily to withstand radial loads. The term spherical roller comes from the shape of the rollers. As you can see, the rollers are shaped like barrels, not like the perfect cylinders you saw a moment ago in the cylindrical roller bearing. The pure thrust roller bearing is very similar to the pure thrust ball bearing you saw a couple of minutes ago. The cylindrical rollers are sandwiched between the two races, which are positioned side by side. Again, this is a pure thrust bearing and is not designed to withstand any radial load. Our final roller bearing is probably one of the most common types in use. It is a tapered roller bearing, designed to withstand both radial and thrust loads. As you may remember, we called this type of bearing an angular contact bearing. You may recall that this is the bearing with somewhat different terminology for the parts. Instead of inner and outer races, they are called the cup and cone on this bearing. It should be obvious now that there is a wide selection of roller bearings in use. To show you what we mean, here is an illustration showing some of the different types of rollers that you will encounter on the job. These rollers can be used in various ways, leading to an endless selection of bearings designed for specific applications. You'll soon find that there are many combinations of both ball and roller bearings that can be used to get the job done. For instance, some pieces of equipment require that you mount two bearings face to face, or back to back. This is usually done on angular contact bearings, like these. On each of these bearings, you will find a designation like this on one of the races that says, thrust here, support here, or something similar. This side of the bearing is the back. and the opposite side is the face. These two bearings would be mounted like this, to be back to back. Or like this, to be face to face. The best policy to follow in mounting bearings in combination is to refer to the manufacturer's drawings for the equipment the bearings are being mounted in. If you have difficulty, refer to the manufacturer's manual or your supervisor. However, here's one important note to keep in mind. If you have to mount two bearings in duplex, be sure they are both made by the same manufacturer. This will help to eliminate problems due to differences in manufacture. That concludes this segment on bearing types and variations. Please turn to exercise number 2 in your workbook.